Okay, the next question we're going to have a look at is 2017 question 6. Diagram shows the square of side length 2k and write down in terms of k an expression for the area of a square. So of course the area is length by width. So in this particular example, area then is equal to 2k multiplied by 2k. So when you multiply the two of these together, well, the 2 by the 2, that's going to give you 4, and then k by k gives you k squared. So the area here is equal to 4k squared. Okay, let's move on to the next part. So an isosceles triangle with side lengths of 20 cm cubed. So we got 20 here, so this is your isosceles triangle. You know it's isosceles because the 20 and the 20 are two sides of the triangle. So as long as these two sides are the same, this is going to be an isosceles. When you're doing this question, it says the hypotenuse of length 2k is removed from the square, and it asks you to find the value of k. So the question is asking us to find the value of k, but in order to find the value of k, you're going to have to find 2k first. So what we've got here is we have a right angle triangle where we know two of the sides, 20 and 20, but we don't know the hypotenuse, which is 2k. So we basically have a theorem of Pythagoras here. So working down through the theorem of Pythagoras, it's your hypotenuse squared is equal to the other two sides squared and added together. So it's 2k, and be careful with this, it's 2k to b squared. It's not 2k squared, which is very different. Equals the other two sides squared and added together. So 2k to b squared is 2k multiplied by 2k. And that's going to give you 4k squared. And as you can see, that's very different than 2k squared. So this is 4k squared. And it equals 20 squared plus 20 squared. So that's 400 plus 400. So that gives you 4k squared is equal to 800. You have k squared then, divide across by 4, gives you 200. So k then is equal to the square root of 200. So k then, when you tap that into the calculator may give you a third, 2 root 2, or 10 root 2. If it does, just hit the change button again and it will give you 14.14. Now the area of the shaded section is next. So now we know that k is 14.14. So anytime in area we're dealing with shaded regions, it's generally the area of the big one, or the bigger shape, and you take away the area of the smaller shape, which is generally the shaded one. So in this one, the area of the big is the complete square. And we worked out that the complete square up here was 4k squared. So the whole square is 4k squared. So the area of the big is 4k squared. We've got to take away the area of the smaller part. So in other words, we have to take away the area of this isosceles triangle. So we need to find the area of this. So to find the area of the white triangle, what do we need to find the area? Well, area for these triangles is actually quite easy. It's half the base by the perpendicular height. So let's have a look at that. Well, if it's 20 here and it's 20 here, 1/2 of the base multiplied by the height is going to be 1/2. The base is 20 multiplied by the height is 20. So that equals 1/2 of 400, which is going to give us 200. So it's 4k squared minus the area of the smaller, which is 200. Now, that doesn't give us an answer. Because how do you take 4k squared minus 200? Well, change colors again. We know from our question over here that k is equal to 14.14. So if k is 14.14, it means we can work out 4k squared minus 200. So we've got 4 times 14.14 squared minus 200. So our final area, and again when you tap this into the calculator, you end up with 599.7584, and that's centimeters squared, and this question asks you to round it up, so that equals 600 centimeters squared. I just realized I put a cubed in there. It's not cubed, that's volume of course, so it's centimeters squared. Okay, on to the next question. So 2017, question 6. Find the distance x in the diagram below, which is not to scale, and give your answer correct to 2 decimal places. So let's have a look at this. Well, always fill in everything you possibly can. In this particular example, this is 65 degrees, this is 63 degrees, and what I would do here is I would fill in this side as well. So 65 and 63, when you add them together, it gives you 128, and 128 from 180 leaves you with 52 degrees in this corner. Now, is this helpful? It is, because what we've got now is we're missing a side, and we have the angle opposite it. We also have another angle and a side opposite it there. So when you have this crossover, this is going to be the sine rule. So writing out your sine rule, what are you looking for? We're looking for this x, this value x, so that goes on top. So it's x over the sine of a equals b over the sine of b. I suppose if you wanted to write it properly, this would be a over sine of a, and then you go fill in the letters. So we've got x over the sine of the angle that it's opposite of x, which is 52. So that equals then b, which is 10 cm cubed. The small letters are always the sides, all over the sine of b, which is opposite it, which is 63. So that means x then is equal to 10 over sine 63 multiplied by sine of 52. You get to 52, you bring it up and you multiply it on the top. And again, same thing, throw it into the calculator, you end up with x is equal to 8.84 centimeters. Let's keep going on to the next one. Find the distance y in the diagram below, which is also not to scale, and give your answer correct to 2 decimal places. So again, we look at this question and see what we have. We can't fill in any of the other angles. So for example, we can't fill in that angle. We don't know what it is, and we can't fill in that angle. And if we can't fill in those angles, that means the sine rule then becomes impossible. So we have to be dealing with a cosine rule. You should also be able to spot it anyway, because you have 53.8 degrees and you have a side opposite it, and then you've got 2 sides on either side of the 53.8. So write down your sine rule, or your cosine rule. So we've got a squared is equal to b squared plus c squared minus 2bc, and then the cos of capital A. And let's put in our details. Now again, as I've said to you before, whatever the angle is, capital A, this is the side opposite. So the side we're looking for here is y. We need to find y. So we're going to pop that in for A. So y squared equals, we're going to fill in all the bits and pieces, and it's going to be the cos of whatever's opposite y, which is 53.8 degrees. Now go back and fill in your b and your c, which are the other sides. So that's going to be 8.5 squared plus the c, which is 10.2 squared, and then minus, and I'm going to have to work this out to make a bit of space, minus 2 times b, which is 8.5, multiplied by c, which is 10.2, and then that's all multiplied by the cos of a, which is 53.8 degrees. When you work out this all in one go, you're going to end up with 73.87897. So when you get the square root of that, then y then is the square root of 73.87897, and that's going to give you your final answer of y. Y is equal to 8.6 centimeters. So that finishes B. 17, this one, question 8, comes up in study clicks. I'm ignoring this. I think this is on coordinate geometry, so I'm just going skipping past this. And that brings us down here to 2016, which is finding the area of a triangle. So this is one of the ones that we haven't come across yet. So we have to find the area of a triangle. So there's several ways of finding the area of a triangle. You can do half the base multiplied by the height, and that's perpendicular height. We don't have the perpendicular height here, so it can't be that one. It's not that one. We can also do 1/2 x1 y2 for coordinate geometry, but again we don't have points. So the only other one then that we can use is trigonometry. 1/2 AB sine C. And even if you weren't too sure, because you're dealing with an angle, then it's going to be trigonometry. So filling in all the details, we've got 1/2. Actually, let's get a better pen than that so you can see it. So we've got 1/2. Now, what are the letters? Well, I always go to the sine C first. So I'm going to make C 30 degrees. So this is going to be the sine of 30 degrees, capital C. And then AB is going to be the two sides, which is here and here. They're the two sides on either side of your angle. So that's going to be 1/2 multiplied by 8 multiplied by 12 multiplied by the sine of 30. Throw it into the calculator and you end up with the area is equal to 24 centimeters squared.